Okay, so just turning maybe to the back of your book or a bit of scrap paper. I just want you, by starting, we're looking at distributive laws, of which there are 5 or 6 laws, all right? The good thing about laws is once they're memorised, they don't change. It's just about applying the right law, all right? So to start with today, we're going to start with the first law. And the first law is something you would be familiar with now. It's the phrase that goes along the lines of you multiply everything outside the brackets by that which is inside the brackets. Okay? Now, we've used that phrase before doing our trial sort of what will now be Year 7-8 maths. Yeah? Is everyone familiar with what I'm talking about? Everyone's on the same page? Yep. So the last, I guess, 4 weeks of learning has been around getting you up to speed to this point. And this first distributive law is a good one because it takes in something you're familiar with. And the phrase is, everything outside the brackets affects that which is inside the brackets. All right? So if we just look at the board at the moment, copy and complete, talk to me about what rules we're using between here and here. Again, it's a rule. Rules are things that remain consistent and constant. So what rule have we used between the first line and the second line there that you should be familiar with, if you like? Rothy.
Brackets first.
Yeah, so what rule is that? What process? Yeah, that's BEDMAS, isn't it? So we're doing this first, and that's using the rule of BEDMAS, all right, which you should all be familiar with. So we do the brackets first, clearly the answer there being 16. The next one, okay, in B, what process have they gone through there? BEDMAS, yeah, multiplication first, multiplication before the addition, multiplication occurs before the addition, okay? Almost like we were looking at our algebra phrases in the last topic where we were almost separating them. Remember we were doing that, okay? So 2 times 5 being 10, 3 times 2 being 6, 10 plus 6 being 16. Can you just very quickly skip through and on a scrap bit of paper, can you just quickly do A to F? And if you have any problems, shuffle your cups and I'll come around and help you. But this is just a very basic beginning to what will be 5 or 6 rules that you'll need to memorise. But once you've memorised them, it's very, very self-explanatory. Okay, so hopefully you've acknowledged that that is 7 times 5, being 35. And I know most of you would have skipped to the chase and you would have done 7 times 5 in your head and you would have said, oh, that's just 35. But provided you got the right answer, that's all right, going through the right process. 7 plus 28, this would have been, which is 35. This one, Tish? 6 times 10, 60. Luke?
12 plus 48 equals 60.
12 plus 48 equals 60, correct. This one, please, Jazz.
I didn't do that.
What have you been doing?
This, because I'm ahead of that.
Oh, yeah. Caitlin?
5 times 7.
5 times 7, being 35. And the last one, please, Emily.
15 plus 20.
15 plus 20, again being 35. Okay. The thing about the distributive law, the first one that you'll see, is that over time, when there's something in brackets, we just multiply that by which is outside the brackets. So if we scroll up for a moment, you can see there the similarities between expanding this bracket, because that's what you do to start with, expand 2 times 5 and then plus 2 times 3. That's the same as what we did back there. So from there, we got that. And from there, we got that. Can everybody see that? 6 times 2 plus 6 times 8. 6 times the 2 times 6 times plus 6 times the 8. All right, so what you did in this process from here to here was that although you got the same answers, what you're starting to do is expand the brackets, which you can see below there. The first rule, so if you can go to your glossary now for me, please. The first rule that I'd like you to put in is Distributive Law 1. And I need you to keep quite a bit of space because, as I said, there's 5 or 6 of these that you'll put down.
So do we write the whole thing, or?
So, no, you just write Distributive Law 1, A brackets B plus C equals AB plus AC. Make sure you put in the arrows because that's going to be helpful for you when trying to solve problems down the track where we don't know all the numbers. Now, for some of you, this is going to further make this understandable, but for some of you, it's just may confuse you. So you make the choice of whether you switch on or off with this, but they do like to do this geometric demonstration that if we had a rectangle which is A, B in length, okay, that solving the area of that would be A times B, wouldn't it? L times W. So A times B, and if we were to find the entire area by doing the 2 rectangles, we'd have A times B, but we'd also have A times C. Okay? So the area of the large rectangle is A, B plus C, that being the total length. Now for some of you that will be okay, alright? You'll find that easy enough to understand. This could also be found by adding the areas of the 2 small rectangles, and this is AB plus AC. Alright, so either way, they equate to each other, those 2 sides. So when we're starting to look at algebraic equations, these are the first ones which may or may not pose us some difficulty. If we were to look at them, everything outside is multiplied by that which is inside. So this is 3 times the 4x and then 3 times the positive 1. Alright? I'm hopeful that when we go through this stuff you can sit there and go, yeah, now I know why we did all that other algebra prior and leading into this. Alright? Because this is where your problem will become, is if you don't remember that the sign belongs to that which comes after it. Alright? That this is 2x times 5 and 2x times negative 2x. Okay? Which is negative 4x squared. Over time, I don't mind if you do this step or not. In fact, I'd probably prefer you, I think with the skills that you have gained from the previous activities, that you should be able to just acknowledge that this is 2x times 5, which is 10x, and 2x times negative 2x, negative and a positive gives you a negative, 2 times 2 is 4, x times x is x squared. So I'm hopeful that that's pretty self-explanatory to you, that you don't have to go through this other process that this book does. Remembering there's some things in this book that I don't necessarily think helps you. And negative out the front, that affects that. So what would we have here, please, Brooke? Negative 2x times by x.
Negative 2x squared.
Negative 2x squared, a negative and a positive. And then, Reese, negative 2x times negative 3. Positive 6x. Okay, so as provided you maintain that that goes with that, and that goes with that negative sign. Put in the arrows on your learning if you want. Students in the past that I've taught have very much appreciated just putting the arrows in to start with. All right? Over time, folks, you might get 6 to 12 digits within these brackets. And to know which ones you've done and which ones you haven't is often assisted by putting in the arrows, okay? So if you feel comfortable with putting in the arrows, I know students I've taught have in the past, go right ahead and do that. That's Distributive Law 1, all right? There's another 5. We might go through another 4. Definitely, we will. Any questions with that? Just get on and start doing some practice ones, you reckon? Yep. Okay. You've got that sheet that's been handed out at the start of the lesson, whether you're in green or blue. So you go ahead with what you need to do there. Shuffle your cups if you need some help. So the volume of the cone, so that was fine for you?
Yeah, I got A and B right.
Righto. Yep, so that's right, that's alright. It's this one, the base of the radius. With that and that and that. So the base radius, so you're finding that. So V equals 1/3 pi r squared h. So V is 30 equals 1/3 times 3.142 times r squared, which is the unknown, times by h, which is 6.2. Okay, so using our calculator, if I can find that really quickly.
Do you want me to do it?
You can to clarify it, yep. That'll be, if we went 6.2 multiplied by 3.142, and if you use pi, that'll be more accurate. And then if we times that by 1/3, all up on this side, we'll have 6.4935 r squared equals 30. Yeah, you're right with that? Something like that. So in order to get rid of that, we'd have to divide that, which would get us r squared. Yeah, but we have to do that on this side. So 30 divided by that. 30 divide 30 divided by 6.4935 gives us 4.62. 4.62. What do we have to do to the 4.62?
Square root.
That's right. Good stuff, Will, because we want to get rid of that. That cancels out that, doesn't it?
Yeah.
So therefore we've got to do that. I don't think I have a square root on that, no. So R equals 2 point something.
2.14. Yeah, that's the correct answer.
2.14, and that's the base radius, and because we're talking about metres, we'd say that'd be metres.
Yeah.
Is that alright?
Yep.
You understood that process?
Yep.
Maybe, I'm just posing this to you, you didn't do this times this at this point.
Yep.
Okay? When you do that, you just simplify it and it becomes 6.4935 times r squared.
Yep.
And then it becomes much easier than trying to drag each one over at a time.
Yep. And I don't know where I went wrong for 3B.
3b. So that's back up.
Yeah.
3b. 3b there. Okay, so this was the momentum question. P equals mv, where m is the, yep. So Sydney hits a 170 gram hockey puck with his hockey stick. The puck travelled with a momentum of 6.8 grams meters per second. what space